Hi, good morning everyone. Thank you so much for joining with us. In this session, we are going to discuss about the steel structures. Okay, in the steel structures, we have a different type of steel structures. One is a conventional steel and another one is a PEB. Okay, what the conventional steel means, so whenever we are studying a BTech, so we already know about this conventional steel that is called I sections, ISMC, ISJC, and these all are conventional steels. Okay, those all will be having some sizes and they can fabricate it in some steel, some steel plants directly. Okay, but come to PEB, pre-engineered buildings. Okay, in the name itself indicates engineer. Okay, see, whatever the loads we are applying on a structure, so we will get a bending moment and shear forces. Okay, by using that shear forces and bending moments, engineer can decide the which section is the best for that. Okay, which type of section and how much is the depth is best for that bending moment. So that is a pre-engineered building. Those will be fabricated in the some warehouses or this. Okay, fabricated. So let me explain you these all concepts in further sessions. Okay, come to here, this picture indicates some pre-engineering building. Okay, so this is not a conventional steel. Yes, we can use a conventional steel also, but using conventional steel is not economical. Okay, and that is not also the design, as in the point of design, that's not best for economical. So that's why we are prefer the pre-engineering builds, tapered sections. Okay, just come to some IS codes. In this session I am going to discuss about some IS codes. Okay, regarding steel structures, we know that we already familiar with few IS codes in the RCC. I mean IS 456 and SP 64 and SP 34, IS 875 part 1, part 2, part 3, part 5, part 6 for those loads, and IS 13920 and IS 16700. These all related to some RCC and steel structures. And in the steel structures also we have some set of IS codes. Let me tell you what are those IS codes. And come to here, some IS codes. See, IS codes and technical books. So in the IS codes and also some American codes. Okay, American standards also. Let me explain you some few things. 1 minute. Yeah. Okay, see guys, here we have means American AISI, American Iron and Steel Institute. Okay, these are the some standard things actually. AISC, American Institute of Steel Construction. Whenever we are going for the design some steel construction in America or somewhere, so we need to follow this ASCI. Okay, AISC. So American Institute of Steel Construction. That American Institute of Steel Construction give you some rules and regulations for constructing the steel structures. At the time, we need to follow this as per the rules and regulations. Whenever we are follow the rules and regulations, then we will get approval and we will get some certified. Okay, certified building like that. See, MBMA means Metal Building Manufacturing Association. So this is the one important code book while we are going for the design of a steel structures, even though PEB. Okay, whenever we are going to design a pre-engineering building, we need to follow this MBMA. Okay, see, it means Metal Building Manufacturing Association. In this MEMA code book, you have all the data regarding design and detailing and everything we have in this code book. And come to here, ASTM, American Society for Testing and Materials. Okay, American Society for Testing and Materials. They also see, but testing purpose, if you have a steel, so how much is the tensile strength, how much is the compression strength for the steel, and these all things will be comes under testing. Okay, and materials, what materials we need to use, is it a C section or I section, cold forms or hot rolled, these things we will get from this American Society for Testing and Materials. And come to here, ASSTM, American Society for Testing Materials, Testing and Materials. It means it's a separate one. In this A section, that deals with the iron and steel materials. Okay, if you go to B, that will be deals with some other specifications. Okay, some other type of materials. So in the A itself, iron and steel, we are mostly dealing with the iron and steel, so we need to follow this one. And come to here, AWS. AWS means American Welding Society. So if you follow some, if you are applying some welding, so that welding must be satisfy the rules and regulations of this American Welding Society. Okay, this is the main important thing. And come to IS codes. These are some some American codes, and let me show you those things also. See this. This is a ASCE. ASCE means, what is this ASCE? Okay, American Society of Civil Engineering and this thing. Okay, so let me come to here. 1 minute. See this, published by American Society of Civil Engineers. Okay, ASCE, American Society of Civil Engineers. Okay, this is an important code book, and I will explain you few things in here also once I completed this. See guys, come to here. Let me show you this ASCE standard. This is the design 7:16. Okay, in before this code book, it is a 710. Okay, so and come to here, minimum design loads and associated criteria for building and other structures. See, minimum design loads. Whenever we are, see, I hope you felt it as I don't need a design. No, don't think like that. Okay, we need to know the design as well. Okay, once you design the building, so you can understand what type of detailing as well. So try to concentrate on both concepts. Whenever we are perfect in a detailing, so you have a chance to go for the designer. So that's this is a one main opportunity we can use it, design engineer. Okay, so minimum design loads. What are the minimum design loads? Comes to here. So let me show you some brief introduction about this code work. See guys, come to here in this index. So some general and combination of loads, how many combinations, dead load plus live load, and dead load 0.1 into dead load and 1.4, and these things we can get from here. And a dead load and soil load and hydrostatic pressure. Okay, hydrostatic pressure comes occurred by some water. And the live loads, what are the live loads we need to apply on the pre-engineering building? Flood loads. Okay, whenever tsunami loads, so and effects and snow loads, rain loads, and reserved for future provisions. And ice loads in sea, in American, see, in America, or mainly it will be snow type, means I mean here how much rainy season, so there is some snow season. Okay, in that snow season, every day the snow is falling on their buildings. At the time we need to design a building for the snow load as well. I mean ice, so ice cubes, those things will be fallen on that roofs. And the seismic design criteria, design requirements for building structure, these all the things they can see. Wind load and general requirements, wind load on buildings, main wind load, wind force resisting system, these all things we can get from this ASCE 716. Okay, so some non-linear response time history and seismic design requirements for non-building structures. And come to here, wind loads on main speed and wind loads composite and cladding. So wind loads on components and cladding. So components means steel buildings, and cladding means some roofs or some type of buildings. Okay, rectangular cladding and these things. And here also wind tunnel processor. Wind tunnel processor, you can't touch this concept, so it will be some another concept. See guys, here is a building explained from the torsional wind load cases. Torsional, so whenever the load will be applied in the one side, so that will create a torsion effect. So that will be. And here also performance based design. Performance based design, how much our building will you give you the performance, that is the main important thing. Performance based design means if you take a steel structure, how much performance that will give you once you apply the load, that is the performance based design. So come to here we have some general and some load combination. These are the some subsections. And live loads, how much is the live load we need to apply on the pre-engineering building? 0.57. If you come to India, so see this, how much live load we are applying in the steel buildings. See, live load will be 0.75. Okay, so 0.75 kilonewton per meter square. Okay, so and come to this is as per IS codes, but come to American standards, the live load will be 0.57 live load. Okay, so 57 kilonewton per meter square of live load. So I think is it meter or meter square? Yes, it's a meter square, no problem. Okay, so this is from American standard. This load will be Indian standard. See this, even you can see Indian as per IS code, IS codes, the live load will be 0.75, but come to American standards, the live load will be 0.57. Even you can say this, so we are taking some higher load. So if you take a higher load, our building will be going to uneconomical. So that type of design. So sometimes even the client will ask, so try to design my PEB building as per Indian codes, as per IS codes, then I will compare myself which one is better, then I can proceed with the one. Okay, so try to, and even client will also ask you, so give me the two designs as per Indian codes, as per American codes also. Okay, that thing we need to know that. And come to here, flood loads, tsunami loads, and once you go to here, let me, due to time being, I can explain you, I can show you the brief concept. 1 minute. Yeah, some come to here. Tsunami loads, wind loads. Where is the wind loads? Okay, 1 minute. This is having so many lot of pages. This we can't find where it is. See, okay, see this. So whenever we are calculating the wind force, we need to take a basic wind speed. Okay, once you get a basic wind speed, so we have some options where we need to. Basic wind speed is the first step, and comes to here. Yeah, see this. So wind directionality factor, KD factor, and here is a wind directionality. So in this, KD is a 0.95 shall be permitted for the round and octagonal structures with the non-axis symmetric structural members. And here is a exposure category, exposure B, exposure C, exposure D. And come to the next one. See this, velocity, pressure, exposure coefficients KH and KZ, and topography factor, and ground elevation factor, velocity pressure, exposure velocity pressure. See, this is a formula we can, this will help you to calculate the velocity pressure on a building. So wind, terrain exposure condition, and gusset factor. Gusset factor for with rigid buildings, other structures is permitted taken as a 0.85. So gusset factor will be, I hope you, if you are new to this concept, you can learn more things from these concepts, so don't worry. So yeah, this is a brief introduction. See this, once if it is your building, so this is in wind in X direction, and this is in a minus direction, and this is in wind Y direction, and this is will be in wind in minus X direction. See, this is your PEB, am I right? This is your PEB. So once you, the load will be, wind load will be applied on this, the wind load will be levered. See, this is the windward, and this one is a leeward. Okay, and come to here, if you apply in the parallel to the cable columns, parallel to here we get a gable columns. So parallel to gable column, the load will be transferred to this one. Okay, so see some suction and those things. Okay, I hope this is all about ASCE 716. Come to here, metal building and system manual. Okay, here I already tell you MBMA code book. So come to here in the metal building. See this, this is the type of building we need to design. This is a PEB building. So here, see how much is the load we are applying it. So see, the 0.75 load will be applied in this negative direction, and this will be a positive direction. Here is a parallel to wind direction. Okay, parallel to gable columns. Okay, this is a how, and here we have it. This in the metal building also load application. How can we apply the load, and the crane loads? How can we take the crane loads? Even though in the crane loads as well, how we can take the crane loads? It's the important thing. So let me explain you free one. See, whenever we have a cranes, in our building, PEB building. So suppose this is your column and this is your column, and here we have a some bracket for crane, and here we have a some bracket for crane. Here this will be the your crane beam. Okay, so gantry gutter, it will called as a gantry gutter. So somewhere here, if you have a crane, and here you have a hook for carrying the material. So see this, whenever, if you suppose take this A, crane A, it's a B. So whenever the crane will passing from A to B, so B load will be 90%, 91%. Okay, and at this load, at this point, A point, it will be the 9% of the load will be acting. So this is some another concept I will explain you in further sessions. Okay, so this is how we can take the crane load, and come to here serviceability criteria and common industry practices, and these all things. So let me show you some things. See this runway supports and total inward. So 1 minute. Yeah, see, yeah, this is important thing. Serviceability consideration, ceiling and partitions, plastered ceiling, how much is the deflection range? So deformation, vertical deflection, how much is the recommendations? Minimum deflection will be L by 360. And so even though we have a steel structures, if you design a PEB, so like this, so whenever you are applying the load on this, so you will get some deflection range. So that deflection will be depends upon these code books, and this is a L by 160 is recommended, like that they will give you. Okay, so here we have a some, see this metal panels and bare frames. So foundation, where is this? 1 minute. Column, so pre-assessed pre-engineered columns L by 4, and these all things we can, this is how we can calculate the deflection from here. So this will be, we will discuss in later times. Okay, so I hope so. And this is how these two, and MBMA and ASC, American Society of Civil Engineers. Okay, these code books will help you to design a buildings as per the American standards. Okay, not Indian standards, American standards. Come to India, so yes, we have American standards. Why can't we follow the Indian standards? So we are in India, so that's why if our building proposed site will be in India, so we need to design for the Indian as per Indian standards. Okay, so, and also particularly if the client will ask you to design my building for the American standards, we need to design our building as per the American standards, even if we are in India. Okay, that's the main thing. And come to here, see IS 800 2007. Okay, 2007. So codes for factories of general construction steel. In BTech you learn all about this IS 800. Okay, if you go to here, so this will be the IS 800. So general code for 1 minute. Bureau of Indian Standards. Okay, so see this these all things we already learned. This design of compression members and design of tension members, and the limit state design, we only follow the limit state design nowadays. So working stress method we never follow this, and the design of compression member, design of member subjected to bending. Okay, so how much is a shear force is the main thing, and the design strength of bending flexural and box cutter, purlins and sheeting rails. So guys, see this purlins and sheeting also. And come to members subjected to combined forces, combined shear and bending, and axial force and bending. How can we design that building? And connections, in the connections also we have some bearing type and friction type, moment connection, shear connection. These things we have some analysis of bolt and weld group and lug angles. So working stress method we never follow this working stress method nowadays. And design of detailing for the earthquake loads, even steel structures also we will design for the earthquake loads. In that how much is the story drift we need to have in a steel structures, and connections, joints, and ordinary concentrically braced frames OCBC and special concentric basic frames eccentricity. And come to here design assist and durability, fire resistance. So see this, if the fire resistance level will be lower, so if any fire will be happen in the industry, that will total will be melted. So this is the steel structures. They have particular fire resistance capacity. Those that one also we need to design it. And fabrication and erection. Erection is the important thing. What will be erection means? Erection means drawings for execution. That's it. Erection means drawings for execution. In RCC we call it as a structural drawings, but in steel structures we call it as a erection drawings. But come to fabrication drawings means whenever we are designing and we did a detailing, so we need to submit to the fabrication by taking this. See, if you have some frame, okay, I section, so we need to, in the PEB we will give you the flange is separate, and the bottom flange is separate, top flange is separate, and web will be separated. Those four uh, they will take into the some area, working area, they can weld it and they can bolt it. So that is the fabrication drawings. Okay, so come to here is some analysis and design methods, and these all things we will get from this 800. Okay, IS 800 2017. And come to here IS 808 1987 for hot rolled steel beams and columns and channels and angle sections. Okay, so let me open this IS 802. This is a 801 and this is a 802. So come to here, see this codes for structural, 1 minute. Yeah, this one. Yeah, this one. See this design of dimensions for hot rolled steel beams, columns and channels and angle sections. In this angle sections, see guys, we have all the angle sections, all these. How can we know that which one is better? See this. See, some of the medium weight beam section will be MB100. Okay, medium weight beam. And come to here, some terminology here we have, and some RS radius of gyration, IA by IY by in A, I in a moment of inertia in Y direction, moment of inertia in X direction, these things. And classification. See guys, this is a classification is a most important thing. Beams, how the beams will be classified: Indian standard junior beam ISJB and ISLB. LB is a lightweighted beam, and the ISMB Indian standard medium weight beam, and Indian standard wide flange beam. Okay, wide flange means, see, the flange will be wider and the depth, the web will be somewhat lesser. Okay, flange will be wider, so that is a wide flange beam. And the columns and the heavyweight beams. Columns also Indian standard column sections ISSC. Okay, and Indian standard heavyweight beams ISHB. Okay, so heavyweight, so it will be create some if you see the our structure will be need to be getting higher loads, then at the time we will use the heavy weights. So that's the main thing. And the channels, Indian standard junior channels, C sections. C, this is this type of C channels. And the Indian standard lightweight channels, Indian standard medium weight channels, MC. And Indian standard medium weight parallel flange channels, ISMCP. Okay, these things. And comes to angle means this. Okay, like this. Okay, channel is like this. Okay, and here columns is the same like this. Okay, and beams also same like this. Okay, some differentiation means some junior beam and the light beam, medium beams, and the depth and width will be somewhat lesser as compared to these things. Okay, and angles will be this one, ISAC, equal angle, unequal angle. This is the two things. See, equal angle means, so if you see this is somewhat 90, so same this will be the 90. Okay, one side will be 90 and the other one side will be 90 depth, so 90 meters something, or 90 mm. So, and come to here unequal, so this will be somewhat 90, this will be getting 180. Okay, like this it will be the unequal angle. Okay, and come to here some beams. See, classification, abbreviations, JBLB beams. Okay, these are the things. And come to here, see guys, if you suppose see this, what is this? Medium flange beams. see depth they will give you here, okay, D. So here is MB100, MB200, MB300 and MB500, these things. See how much is the thickness also they mention here, okay. So from these values, by taking this picture representation, you can calculate you can take these all the values and radius, flange slope, this one, flange slope or radius. How much is the flange slope or radius? Gamma, where is the gamma? Yeah, I think, yeah, this one. So how much is the 98 something? Okay, 98 from here to here. Okay, this is all how we can read these code books. That is the important junior beams and light beams, and these all the things you will get a all the information. Okay, this is a C channel. Okay, see top to bottom depth from end to end, how much depth. If you suppose you just take it as MC, medium weighted channel, so it will be the 200 watt. This 200 is what? See, come to here, depth D will be 200. So, and come to breadth 75. So where is the breadth? Say here. Okay, here is the breadth. So this and come to here, C angle, and here is a, so this is the L sections, equal leg angles. Okay, and come to non-equal leg angles. Yeah, this is, see guys, this will be somewhat lesser and this will be somewhat higher. So even you can check it from here. Okay, this is all about this IS 1891, IS 808. Okay, so hot roll beam, column channels and angles. And come to here, IS 801 1975 for cold formed light gauge steel members, cold formed. So what is cold formed? Let me discuss about it here. Cold formed, see, hot rolled, cold formed. So we have two things, hot rolled, cold formed. Hot roll means in the that will be fabricated in steel, what is that, steel plants, or these, though these all will be hot rolled. These whatever we are discussing right now, so these ISMC, these all will be hot rolled. But come to cold forms, these will be some sheetings and some purlins, and these things will be this means what is that, cold formed. Okay, so you can get what are the information in that, you can get here. Okay, design procedure and purpose of properties of sections. And come to here, let me show you, yeah, stiffness and compression element. If you wanted to design the cold forms, you can design by using these formulas. So usually wide flange, okay, how much is a wide flange we will get, and the maximum design ratio, effective design width to actual depth. So these are, by using these taking these values, we can decide that cold form sections. Okay, this is all about the cold forms. And come to here, IS 802 1978 part 1 section 1. So here we have a part 1 section 1. This will be deal with the tower and loads. So tower is come to here, where is that part 1 section 1? Yeah, this one is the part 1 section 1. So see this code of practice for use of structural steel in a overhead transmission line towers. Okay, transmission line towers. And part 1 materials, loads and permissible stresses, section 1 materials, loads. Okay, this thing, come to here, let me show you what is this. So 1 minute. So this is a somewhat terminology, you can study this terminology. And come to here, some angle, small angle towers with the 0 and yeah, 1 minute, some terrain rough. Yeah, this is a wind design. So wind, how can we calculate the wind design? Come to here, see, wind effect, basic wind speed. This will be come from this code book, IS 875 part 3. Okay, so these IS code, loading code books, I will discuss you some another concept. Okay, another session. Okay, so IS 875 part 3, actually recently it will be changed actually. So it's 2015. Okay, so 2015 they make some modifications, then we can take that updated code. But see here, this is a meteorology of India. So here reference basic wind speed, based upon your location. Okay, if you suppose you are in Vizag, so our wind speed will be 50. Okay, if suppose you are in Hyderabad, that wind speed will be 44 nearly. Okay, so that will be basic wind speed will be depends upon what, so location. So that location where we will get this, that will be clearly mentioned which city, and that basic wind speed will be getting from this IS code book. Okay, that we will discuss later. Okay, come to here, design feed VB and K1, these all things will be some another, by taking these loads is an important thing. So whenever we are applying the building, means a PEB wind load, that is a, see guys, here in this, so suppose we are in this zone. Okay, so in this level Visakhapatnam, somewhere in the sea coastal. Okay, so this will be red mark, red mark comes under this one, so this will be 50. Okay, by taking this graph also you can decide how much is the wind speed acting. Okay, see this, this is a transmission tower. So see this horizontal configuration of tower, this here, see guys, so whatever the work we are doing is design of steel structures, that will be in the top, bottom means superstructure. So substructure comes to substructure, here we need a concrete RCC design engineer, so he can take these reactions and he can design this concrete. Okay, so by taking these reactions, tower corner, these fixed reactions, he can design the concrete. He will decide the how much is the footing size required. Is this a file foundation or a raft foundation? He can design it. Okay. See this windward faces. This, if suppose a wind will be acting in this direction, this will be the windward force, and another side will be leeward. Okay, so suppose if the wind will be acting on this in this direction, this will be the windward direction, this will be the leeward direction. Okay, so like that we can design it. And come to here, so 1 minute, yeah, tension limit, how much is the tension? Initially unloaded tension will be 35%, and finally unloaded tension will be is 25%. If you are applying the load on the some material, so how much is the initial load and the tension percentage as well. So this is all about this IS 802 part 1 section 1, and come to section 2, part 2 and section 2, permissible stresses in towers. Okay, let me open that. Yeah, 1 minute. So this will be the permissible stresses. So in the tower, how much is the permissible stress? So yeah, we'll come to here. 1 minute. Yeah, this is an important thing. Effective slender ratio, KL/R. KL/R is a important thing. Okay, based upon this we can decide is that section is fine or not. See, come to here, this will be the code book for erection. So I hope this one will be that IS 83. No, it's not something other one. Okay, come to here, 1 minute, let me come to here. So this is axial stresses in compression. So how much is axial stresses in compression side, and some ultimate stresses in bolts. Even the bolt also we need to design. Okay, in that bolt how much is the ultimate strength getting from the bolt, and as per slenderest ratio, see leg angles or joints members bolted, so L/R will be, see this, less than or equal to 120, and here is L/R will be less than, only less than, not equal, so less than 120. And this is, see here we have a value of KL/R. So, and come to here, redundant members we already studied in a BTech. Minimum thickness, so how much is the leg angle minimum thickness? We need to go for the 5, or painting, with the painting it will be, the thickness will be the 6, 1 person 1 mm will be painted. Okay, we need to paint on the surface. Steel structures, it will be going to rust, so that's why we need to give the first, we need to make a blasting means some sandpaper rubbing, and after that we need to apply the, see in the steel towers also, minimum diameter of the bolt we need to use a 12 mm dia, and the preferred size of the bolts 12, 16, 20. Okay, we need to follow these code books. Okay, otherwise how can we decide it how much is a bolt we need to use? So these are the code books will help you to design initially. Okay, so see this guys, leg angles for using symmetrical basing. So this is the somewhat another some small part of the this tower, and this will be the another part. And here is a we already seen that battens, and some in our BTech we design these battens. Okay, battens and bracing, these all things we already design in a BTech, but again you need to refer once again. Okay, so then you will get a better understanding how can we design this. And this, see this, this is the section view for this. Okay, and this is how I see, guys. If suppose expressing without secondary members, if you don't use the secondary members, how can we use the expressing? So that will be here. And even also you can calculate the center ratio also. So this is a tower, and this, see, we can see this all the towers in normally in some sites also. Okay, so this is all about the towers and the permissible stresses. And come to the last one, see this IS 13843 1989 is for tolerance of erection, tolerance for erection of steel. Erection, how can we, I already told you that what is erection. So erection means site execution purpose. If you just design a building by using StatPro, you detailed by using BOCAD, and you need to give it as these BOCAD drawings to the fabricator. So guys, let me tell you the methodology. 1 minute. So see this, first of all, the client will come and ask me to design I need a PEB structure. Okay, I need a PEB type structure. So at the time, what we need to do, we need to initially give a quotation, how much is the steel and how much is the quantity required for that area. Okay, and after the quotation we will decide the grid spacing. Okay, spacing of the grid. And by taking the spacing of the grid, we will decide steel sections. Okay, how much is the steel sections? Okay, by using a StatPro. Okay, and once the StatPro is done, so we need to give it to the detailing person. So that is in BOCAD. So BOCAD. Okay, the BOCAD, once the BOCAD will be over, our drawings will be going to the fabricator. Okay, fabricator. Once the fabricator will be gone, that will be going to the QC, that will be not under us. Okay, don't leave it, QC, quality inspection. And after that fabricator, that will be going to the erection. Okay, erection, we need to, as a design engineer, he need to draw only the StatPro model. You need to check everything is correct or not, and that structure is structures is enough for carrying those loads, wind load and earthquake loads. And once the StatPro design work is done, the detailing work going on. And in that BOCAD, we need to model a building, and after that some error checks. So is that everything model will be correct or not? And we need to make a drawings for the demo purpose. Just making one frame, we need to check the drawings, is that drawings will come as correctly or not. So once that, okay, once it's correct, we need to draw entire slab, entire project. And after that we need to create a bomb, build of materials. Okay, bill of material. Once the bill of materials will be completed, okay, once the bill of material will be completed, what we need to do, we need to create the fabrication drawings. And once the fabrication drawings will be over, so we need to go for the erection drawings, preparation of erection drawings. Okay, this is the entire procedure for as a structural steel designer engineer. Okay, structural steel detailing and design engineer. Okay, so this is the main thing. And come to here, tolerance for erection of steel. Tolerance means, okay, if suppose, let me show you that code book. So tolerance, where we will get a tolerance. Okay, 1 minute. Yeah, guys, see this deviation. So deviation of column axis at footing top level with respect to the true axis. See what it means. See, suppose if you have a footing here, okay, and we have a pedestal here, one pedestal. In this we have a steel structures. Okay, steel structures, that is the I section. So for the true axis, this will be the true axis, some footing true axis, some xx. Okay, and come to here, what it will means, deviation of column axis at footing top level with respect to the true axis. But our column axis will be somewhat here, somewhat here in this position. This will be the y. So how much is the deviation? It will be allowed. So if suppose in the longitudinal direction, it will be plus or minus 5 mm. If suppose this deviation will be more than 5, so we plus or minus 5, so we supposed to not accept that thing. Okay, we need to correct it, we need to make it as a exactly in the true axis. But suppose this will be the 3 plus or minus 3 mm, so we can neglect it. The tolerance limit will be plus or minus 5, so it will be the tolerance will be the error will be 3, so no problem, we can leave it. So like that we can get all these data from here, the tolerance for the erection only. Okay, so and also if you go to here 800, so you will know how much is the depth and width. See, bolt gauge length and these things, it means, see, if you have a base plate here, one base plate, and here we have a some eye section here. Okay, in the eye section we have a wall holes here. Okay, in these holes we have some holes here also. And how much is the distance from here to here, this will be, we will get from the code book. Okay, so and this thing will be, and as a some experienced persons, they can easily say this will be this much we need to maintain. But initially we need to follow the code book. As per the code book we can decide it. Okay, how much is the tolerance for from here to here, how much is the tolerance, and the pitch distance, and from here to here, and gauge distance, these all things will be, we will get from the code book. And you need to search on the code book, will be 800. Okay, 800 code book. In this code book we will get all those results. So try to focus on this code book. Okay, what's which code book, 1 minute. Yeah, IS 800. Okay, so okay, so come to here, and one thing is, let's okay, these all things about IS 87 IS codes. And come to the technical books, some technical books. 𝗘𝗧 technical handbook. Okay, 𝗘𝗧 is one of the MNC company. Okay, that will deal with all the steel structures, different type of steel structures in the all over the world. So and come to here is the 𝗘𝗧 technical handbook. Let me open that technical book. Yeah, 𝗘𝗧 building systems and technical handbook. Okay, so this is a building, and here you can see all the see guys, here we have some PEB skeleton structure. Okay, here we have some structures. Let me briefly explain this. This one is a concrete, guys. This is a concrete for footing, and here we have a pedestal, and this is a concrete, and this one, the total below the structure, below this flooring will be the civil engineer work. Okay, civil engineer work. And come to the above, this will be, we can do the mechanical engineer as well as civil engineer. Okay, mechanical engineer as well as civil engineer can do the work of this PEB. Okay, so and come to here, this will be the column, and this will be the rafter. Okay, and here this is also column, and these are the gable columns for resisting the wind force. Okay, gable columns, these are the gable columns. This will be the main column. Okay, main middle column. Okay, and come to here, this will be the gutter. Okay, means gut. Okay, and here we have a top, this will be the purlin. Okay, these things I will explain you briefly. And this will be the crane, this is the some path, and also crane. Okay, so crane, for carrying this crane we have a, see this, here we have a crane beam. Okay, this will, we need to design it. And this is a mezzanine floor. Okay, mezzanine floor in each see, here also we have a floor, and this will be, we can make it as a concrete. Okay, concrete, precasted concrete or something. And here we have a staircases. And come to here, is there any, yeah, if you suppose, if you just make some sheeting here, that will be the sheeting. Okay, and come to here, this will be the windows. Okay, and we have some sag rods here, sag rods. Okay, so like this sag rods. And here see, we have a bracing here, bracing. That bracing, why we are using the bracing, I will explain to you. Okay, and come to here, where is that? Yeah, but yeah, some ridge ventilator, and some ventilator type glasses, and those things we will get it. And some in the corners also we have a gutter strip, and some canopy. Where is the canopy? So I think here there is no canopy. If suppose, see this is a portal frame, portal frame. Yeah, this will be the portal frame. Whenever we are dealing with some high project, so means a type of a long span and having a higher steel, we need to provide this portal frame. Portal frame will be, see attaching with the one beam with this column and this column, and here also one small columns. Okay, these columns, and this will be the beam. Okay, portal beams, and come to here sag rods and remaining things. Okay, yeah, this is all about the PEB, and come to see this technical Kirby technical book will be help you to know the more things in a PEB engineering specifications, standard structural systems, and engineering data. Okay, some purlin and GERT and eve GERT will be come in the side, and the cold formed C sections will be placing like this. Okay, and also we can use the jet sections as well, and these things we can discuss in some other types. Okay, special structural PEB engineering building, special structures, multi frame frames and trusses, multi, and these things we will explain it. And the accessories as walking doors, sliding doors, rolling doors, and roof curbs and roof jacks, windows, lowers, and these all things we need to use in a PEB. Okay, and the installation details, end wall details are purlin, gut, connections, and the bracing details. Connection is one of the most important thing in a pre-engineering building. In the building means steel structures as well. Okay, connection, and come to one. Okay, this is see, let me show you some pictorial representation as well in the C, guys. Okay, so vertical fascia details. See, if you wanted to make a fascia, any fascia here, see, even you can see this in the first, at very first we will see the fascia. Let me show you. So remember this fascia. Okay, so how we can place the fascia, and here see this is a C type. Okay, and this is a sheeting. Okay, and this is also sheet type, this one. Okay, C type purlin, and here is, yeah, this one is exactly seating, and this will be purlin. So if it is in the top, that will call it as a purlin. If it is a side, okay, if you place a side, that will be called it as a GERT. Okay, GERT. Okay, and yeah, so let's come to here. Where is this? Yeah, this will be the somewhat vertical manshed. Okay, so 1 minute. So come to here. This will be the seating details. Yeah, see this is a ridge flashing panel. Okay, ridge panel. See, whenever we are designing this sheeting, so even we have a chance to go the rainwater from here. Okay, at that time we need to provide us some ridge panel. Okay, ridge. Okay, ridge flashing. So this is only the sheeting. So only small amount of this covering material. Okay, covering this gap. Okay, and some roof. This will be the roof. Okay, this is the sheeting. Even in our homes also we can see this sheeting. Okay, and this is a bolt for the, see, this is another sheet, and this is another sheet, and by taking lapping these two things we can apply the bolt here. Okay, so that is the main thing. And okay, this is all about this Kirby technical manual. And let me go to another one. See, what is the vertical fascia? See this, even you can see the vertical fascia here. Yeah, see this, guys, this will be the vertical fascia. Okay, so here, and come to next one. So next technical handbook will help you the 𝗲𝗡. Okay, 𝗲𝗡 steel technical manual will help you to know the concept in a pre-engineering buildings. Okay, that will be come to 𝗲𝗡 steel 1 week. Okay, let me show you that. Yeah, see this. So guys, here aim of this material, leave it, and 𝗲𝗡 steel organization, advantages and steel literature, and initial packing order. Okay, come to here aim. So just leave it these things, and see, guys, these are the some this is the frame we need to design it. And in the next session I will tell you the design concept, why the pre-engineering building was invented. So that I will next cover in the next concept, why this will be like this, why it will be somewhat taper here, some lower section here, why it will be higher section here, why it will be again lower here, why higher here. Okay, that concept I will explain you in the next session. Okay, so this is a Z section, and this is a Z purlin and C purlin. And yeah, see this is a tapper for this means rafter and column, this type of see, in the here it will be depth 300, but come to here it will be 600. Okay, like that we can design it and see the how we can make the all these things. Okay, and come to here. So this book also will help you to see inside it will be like this, but outside it will be like this. See, these all things will be going for the some showing purpose. Okay, but outside inside it will be somewhat PEB. Okay, so why we are providing the buildings instead of RCC? Okay, why we are using the PEB instead of RCC? That will cover in a question and answer sessions. Okay, so yeah, these are the things. Let me show you some technical concept. Yeah, finishing coating, and this is how we can give the quotation. So permanent and the width of the ranges and the dimensions, color bond, and those give you the specifications. See base metal, see ASTMA, okay, grade, and this is a galvanized sheet, and see these things. Let me 1 minute. Yeah, guys, see this how we can attach these connections and the purlins and these things, and these all things we will get from here detailed concept. See, here we have a I section, C section, and here we have a C section, here we have a I section. They will place make a plate here, they will use a L angle, and see this L angle. See guys, here is a L angle, so by taking this L angle they will bolt here and they will bolt here as well. So this is how we can take this. So see this is a sag rods. I hope this sag rods. Why these sag rods will help you, why we are using the sag rods and base rods, and that technical concept I will explain in the next session. Yeah, this is a ridge panel. See guys, I already explained you, this is only the ridge panel from here to here only. Okay, same sheeting that will be cutted in the different shape. Okay, for action, you see here is a gutter strap. Okay, and this will be the vertical gutter. Okay, so and here is a wall panels and side wall gut. So this will be the side wall gutting. Okay, if it is in the top, that will call it as a purlin. If it is in the bottom, it will call it as a gut. Okay, and the cable bracing. Yeah, this is a bracing. So this bracing. Okay, and some, where is this? Yeah, downspout carrying the water. Okay, downspout will be help you to carry the water, rainwater. See, whenever the rainwater, see, let me show you. So 1 minute. Yeah, see, suppose this is your PEB one side. So whatever the rain will be falling on this sheeting, that will be collected by using the gutter. Okay, gutter strip. Okay, by taking this gutter strip, so we need to provide some downspout. Okay, per pipe, just a pipe that will be carried to the downside. So this gutter strap will place every 2 meters or 3 meters or 5 meters. Okay, depends upon our wish. Okay, that will be downspout, that rainwater will be flowing on the ground. Okay, so that's, and this is a connection. Okay, this is the flange braces. Okay, flange braces. So by connecting, see this, if you have a ridge here, rafter here, so we will place C, Z or C. So we need to connect with the rafter. Okay, that flange braces will help you to design some tension member as well. Okay, tensioning. Okay, so this will be the connection for bracing. Okay, I hope this is all the, so you can go and check all these options. If you have any doubts, you can ask me. See, this is how we can cable bracing and rod bracing. This is a hillside watcher. Okay, hillside watcher. Okay, this will, okay, and here we can make a hole for the web of the rafter. Okay, then we will place here, and after that we will place a hillside watcher and we make it as a bolt. Okay, so this is, and yeah, these are yeah, this is a portal frame. This will be the portal frame. So I already told you, portal frame angle brace. This will be the angle brace, and this is a portal frame. So yeah, these all things we can cover. Okay, so this is a, see, these all things will be gutter, means gable columns. Yeah, these will be gable columns to resist the wind in the long, means these gable columns only be in the means last bay. Okay, only in the last bay. In the middle bay you never get any gable columns. On the ends of the both ends you will get a gable columns. Okay, this is a hinge connection, and this will be the rafter connection and column connection. Connections is the most important thing we need to make as a connections. Okay, these are the c type. See this, you can see here z gut. Okay, so and this is how you can see this. And I hope these two technical books will help you to know the very much knowledge, and I'm also learn all those about from these two technical books as well. And I hope this will be clear. I hope you learn all the IS code books and American standards and some technical handbooks for learning these things. And in the next session we will discuss about a few more concepts, okay, regarding design and everything. Okay, I hope this is clear.